Today we are diving into the world of Prometheus. For me, as a front-end developer, the domains that require extensive architectural knowledge can sometimes be challenging. And here I'll try to explain in the simplest terms possible what Prometheus is, and together we will take a look through its architecture. So let's get started. Every time I encounter a new framework or technology, I make an effort to understand its technological stack, its runtime environment, and other relevant details. So, what is Prometheus? In simple terms, Prometheus is a server written in Go that covers different aspects of observability. Prometheus finds its application in various industries and scenarios due to its ability to effectively monitor and manage complex systems. Typically, this involves multiple servers running containerized applications with a lot of interconnected processes. And sometimes you can see one error, but not even suspect how deep the problem is and what it might be related to. So every time DevOps asks yourself where the error is it hardware level? Is it application level? If it's application level, where exactly? So Prometheus is designed to either answer these questions or anticipate possible problems. Okay, so let's take a closer look at the Prometheus architecture. I would divide it into three main parts. The first one is Retrieval. It pulls metrics from apps, services, or servers. They're usually called targets. Then receiver puts this data to storage that stores metrics data in time series database, and then HTTP server can use the stored data to query it using provided web UI, or can provide an API that can be used by external platforms like Grafana, for example. Okay, so let's take a closer look at each part of the architecture. The first one is retrieval. In Prometheus, retrieval refers to the process of collecting metrics data from targets, which are the entities being monitored. Retrieval involves querying HTTP endpoints exposed by these targets to fetch metrics data in a specific format, usually at regular intervals defined in the configuration. It's always slash metrics endpoint. Yeah, there is a corner case here. Since Prometheus scrapes metrics at the regular intervals, there is a problem when it comes to short-lived jobs. So for these purposes, there is a push gateway where short-lived job pushes metrics on exit. Then Retrieval can scrape metrics from this push gateway. Okay, so let's talk about metrics endpoint and exporters. By implementing an HTTP server with the slash metrics endpoint and formatting metrics data according to the Prometheus exposition format, targets enable Prometheus to collect metrics information from them effectively. Some services natively support Prometheus slash metrics exposition, while others don't. In cases where services don't support it, exporters come into play. Exporters are additional component used to expose metrics data from systems or services that lack built-in support for the Prometheus exposition format or lack instrumentation for monitoring. And yeah, as we see in this diagram, um, this exporter helps this server to collect needed information and then convert it to Prometheus metrics format, and then Retrieval can scrape this metrics from that exporter, but actually from this server. Okay, so let's talk about service discovery. Uh, if our set of targets is dynamic, Prometheus utilizes a process called service discovery. This automated mechanism enables Prometheus to identify and monitor endpoints, targets that expose metrics. Service discovery functions by regularly querying different systems or platforms to locate targets based on predefined criteria. These criteria might be involved DNS records, Kubernetes services, AWS EC2 instances, or other metadata supplied by a cloud provider or orchestration system. For instance, within a Kubernetes environment, Prometheus can autonomously discover and monitor new pods or services as they are deployed or scaled up. So now let's talk about metrics format. In Prometheus, metrics are presented in a text-based format known as a Prometheus exposition format. This format is human readable and standardized. It contains from 5 parts. First one is a metric name. The second one is labels. Labels provide additional metadata associated with the metric, allowing for more detailed categorization and filtering of metrics data. Label consists from key value pairs. Then third part is value. The value component of a metric represents the actual measurement or observation being recorded. Then comments. Comments can be included in the metrics data to provide additional information or context for human readers. And timestamp. Each metric data point includes a timestamp indicating when the data was collected. In Prometheus, timestamps are basically not included as a part of the metric data itself. Instead, Prometheus uses its internal time series database to associate timestamps with metric data points upon ingestion. Yes, when the metric data point is scraped or collected by Prometheus, it is assigned timestamp corresponding to the time of collection. This timestamp is then used by Prometheus for querying, aggregation, and visualization purposes. Here we have a type of metric called counter. Let's find out which types of values we can collect. There are 4 of them. Gauge. Gauge is a type of metric used in Prometheus to represent a single numerical value that can go up or down over time. It can be negative, and it's commonly used to track values that can fluctuate, such as CPU usage, memory usage, or number of active connections. Counters is a type of metric used in Prometheus to represent a cumulative value that only increases over time. It can't be negative. Histograms in Prometheus are a way to track and analyze the distribution of values over the time. And for example, imagine you have a group of people and you want to know their ages. Instead of just getting the average age, a histogram would break down the ages into different groups, like, for example, from 0 to 20, to from 21 to 40, and from 41 to 90. And this gives you a more detailed picture of the age distribution rather than just a single average number. There are also summaries. Summaries are similar to histograms, but they tell you important things about the data you are monitoring, such as how fast it's changing and how spread out the values are. The last topic of retrieval, let's talk about its pull model. Pull mechanism is an advantage of Prometheus. Unlike other tools that wait for data to be sent to them, Prometheus actually goes out and gets the information it needs. This helps avoiding overwhelming your network with too much data. Let me show you how push mechanism works and describe its problems. Push model includes a single collection platform where all your services push metrics. This approach requires a special software to be installed to push metrics from each service. Another problem is network overhead. Pushing metrics from the network from multiple services to a central monitoring system can generate significant network traffic, especially in large-scale deployments. This can result in increased network latency and bandwidth consumption. Also, push model introduces limited visibility problem. The central server might not have a complete picture of what's happening with all the devices at any given moment of time because it relies on the devices to send updates to it. This limitation can make it harder to detect issues or troubleshoot problems quickly. So, for example, this server can't tell if it's up and running just because of network problems. Okay, so now it's time to define our second part of diagram, storage. Storage in Prometheus is basically time series database. TSDB is designed to efficiently store, retrieve, and analyze time series data. They often provide specialized features and optimization tailored to the characteristic of time series data, such as high ingestion rates, efficient storage mechanisms, and specialized querying capabilities optimized for time-based operations. Okay, so this is it about storage. Let's go to the Prometheus HTTP server part. Yeah, this one. HTTP server is a component responsible for handling HTTP requests, serving metrics data, and providing a web-based interface for querying and visualization. It exposes endpoints for scraping metrics data from monitoring targets and serves the Prometheus expression browser, allowing users to interactively query and explore metrics data using Prometheus. Prometheus is a powerful query language used to retrieve and manipulate time series data stored in Prometheus. It allows users to perform various operations such as filtering, aggregating, and transforming metrics. Also, it contains different sections where you can find configured targets, check TSDB status, and other information. And last but not least component is Alertmanager. Alertmanager is not a single fixed solution, but rather a pluggable component allowing users to choose different Alertmanager implementation based on their specific needs and preferences. Let's break it down using this diagram. First of all, we need to create a configuration file for alerting rules. Then Prometheus constantly evaluates these rules based on the metrics it collects. When rules condition is met, Prometheus flags it as an error internally and pushes it to Alertmanager. Alertmanager then decides what to do with each alert based on its configuration. Uh, yeah, and then finally, Alertmanager sends out notification based on its routing decision to Slack, email, etc. Okay, so to start monitoring, what I need to configure? To answer this question, let's ask ourselves the following questions. What do I want to monitor? For it, I need to define my scrape targets. When do I want to be alerted? For it to answer, I need to configure alerting rules. It can be done in Prometheus YAML file. How long do I want to keep my data? This is about storage configuration. And where do I need my alerts to be sent? This is about Alertmanager configuration. Do I have a dynamic targets? If yes, I need to configure service discovery. Okay, that's a wrap. I hope this information has been clear and helpful for you. Thank you for watching and happy monitoring.